2,982 new cases.
At last count, Italy recorded more than 3,400 deaths.
As a record-setting weekend in the coronavirus pandemic.
During the COVID pandemic, we learned that one thing that keeps the world running despite disease is vaccines.
I think vaccines are very important in order to prevent infectious diseases so that we can reduce morbidity and mortality around the world in infectious diseases.
First death due to the Delta Plus variant.
But not all diseases get the same attention, and vaccines are still missing for many severe diseases. For some, there is a vaccine, but then the vaccine doesn't work against all the variants. This is the case, for example, with the pneumococcal bacterium, which causes both pneumonia and meningitis.
Well, pneumococcal infections are major causes of morbidity and mortality worldwide. And it's estimated that about 1.5 to 2 million people die from pneumococcal infections every year. So here on this picture, we see pneumococcal bacteria, and they are usually found in short chains. But often they are like this, diplococci, 2 and 2. And if you use high-resolution microscopy, we can also visualize the capsule. And the capsule is the target for current vaccines.
The capsule is important for today's vaccines because when you create a vaccine, you look for something unique about the bacteria that our immune system can easily recognize and form so-called antibodies against. When you are later exposed to the real bacteria, the antibodies are ready to activate the immune cells that kill the bacteria. With pneumococci, the capsule has been chosen. The problem is that it looks different for the 100 different varieties that exist of the bacterium. And the vaccines we have today can only handle up to 20 of these capsule variants.
The risk is that we will select for variants that are not covered by the vaccines, that will be more common, causing infectious diseases.
Birgitta Henriques Normark now wants to develop a better vaccine, which can knock out all of the pneumococcal bacteria.
It's going fine. We grew.
It was when Birgitta was working as a young doctor that her eyes were opened to how little was actually known about such a common and dangerous bacteria. That was the start of her research.
I worked with pneumococcal infections for around 25 years, but it's a pretty tricky bacteria to work on.
But through her research, she has learned more and more about the bacteria. And now, she has something in the works.
Do you have the pictures ready?
Yes, I've been looking at some membrane vesicles.
They have been on the hunt for a new vaccine target for the bacterium for a long time.
So what we see here, the bigger ones, these are the bacterium. But here in between, excitingly, we can see these small bubbles here, and they we call vesicles. And these are the ones that we became very interested into.
And soon they managed to capture how the bubbles formed on the surface of the bacteria.
And then you can concentrate on looking here. And you will see here, you just saw one vesicle popping out from the bacterium. And this we thought was very interesting and exciting. And we thought that maybe we could use these vesicles as a vaccine.
Here we can see when a bubble releases from the surface. Could these nanometer-sized bubbles be the solution they have been looking for so long?
Hello, Jens.
Hey,
How is it going with the experiments?
it's going good. Just now.
Now the work begins to try to create the new bubble vaccine. They grow the bacteria on plates. They detach the bubbles from the surface of the bacteria, clean them, and create a first dose.
There. Now it's ready.
They are ready for the first tests, but not with a syringe. They let the mice get the vaccine as a nasal spray. After a few days, they are introduced to the bacteria, Will the mice's immune system now recognize the bubbles and create a protection? The result is clear. The vaccine provides complete protection. But how does it work for the many other varieties of the bacterium? They all form bubbles, but they look a little different. They try one by one. And it works surprisingly well. The vaccine provides 90% protection against all the other variants tested.
We are very satisfied. We think we have been very successful, but we need now to see that we can get 100% protection to all pneumococcal variants.
These bubbles look like a very promising candidate for a new vaccine. And quite possibly they can set their sights even higher. Because the small bubbles, called vesicles, are found on other types of bacteria as well. Bacteria that cause staphylococcal infection, blood poisoning, and tuberculosis. Can they maybe make new bubble vaccines against them as well?
Well, now we are developing vaccines against pneumococcal infections, but we hope and envision that we will also be able to develop vaccines against other infectious diseases using these bubbles, so that we can reduce morbidity and mortality worldwide.